Okay, so next we can see the BGP neighbors come up. So if we look at the show BGP, VPN v4, unicast all summary, we should see that we are receiving routes in from router 11. Now, as I had mentioned before, one of the changes between InterAS option A versus B and C is that now, since we're exchanging VPN v4 updates end to end, the route distinguisher and the route target value have global significance. So what this essentially means is that from router 3's point of view, if we look at the show run VRF, so this is from the PE router, and the PE router is doing an export route target of 100:100. This is now what XR1 needs to import. So likewise, if we show run VRF, we need to make sure that these numbers are going to match end to end. Now, we will look at a little bit later, there are some ways to work around this if the number is not the same. There's a feature that's called the route target rewrite. But the point is that just like intra-AS L3VPN, this number determines the route's VPN membership. That if it doesn't match, you don't import it into the VRF table, and then you cannot advertise it to the customer's table. Okay, but in this case, the VRF policies do match between them. So VRF A is 100:100, VRF B on router 2 is 200:200. So we can see router 1 is getting the routes. If we look at the show BGP, VPN v4, unicast all, we can see that we're learning 4444 and 8888. Those are the eBGP destinations. And then if we look at on router 2, show BGP, VPN v4, unicast all, we're receiving the route to 8. And then we should be redistributing this from BGP into IGP, and it should now go to the final customers table, which in this case, the customer is router 10 for VRF B and router 7 for VRF A. So if we go to router 7, who's in A, and look at the show IP route, we should be seeing the remote destinations like the 10101010 that is, or not 10101010, which one should this be? This should be, and actually I think this will come back to, I think 3 has a misconfig on it that I missed when I was pasting stuff in. Let's look at this from 10's point of view. So if we show IP route, we see 8888. There was a question here. So I did apply next hop on changed on iOS XR. And hold off on that question, I'm going to come back to it. The problem that I had run into before with it, why it is an issue, it's basically not supported on iOS XR not to leave the next hop unchanged. But once everything's working in the data plane, then we'll come back to that. Okay, so from router 10's point of view, we know how to get to 8888. If we go then to router 8 and look at the show IP route, we should see here that we are learning the route to router 10, and then likewise from router 4, if we show IP route, we should be learning the routes to the other side. Okay, so let's take a look at why the routes are not getting between the customers. So we saw that router 1 had the prefixes. It was reflecting it to router 2, it was reflecting it to router 3. Router 2 did advertise it into the VRF table, and we see that router 10 is learning the prefix as an IGP route. Okay, notice here that this EIGRP route is an internal route, not an external route as we saw in option A exchange, because with option B and option C, the route is staying VPN v4 end to end, which means that the EIGRP cost community or the BGP cost community for the EIGRP vector attributes is maintaining itself in the VPN v4 update, and then the same would be true of OSPF. The OSPF route target, the OSPF domain ID, that's going to stay in the encoding. So those same rules that we talked about for PE to CE routing with OSPF and EIGRP, these now maintain end-to-end between the inter-AS peers. Okay, so next let's look at router 3 and C. Did it receive the route for that particular VRF? If we look at the show BGP, VPN v4, unicast, all summary. Okay, we see we're learning routes in from router 1, and if we look at what routes specifically they are, we are learning 4444, and then we should also be learning 7777. Okay, that's the one that's coming from IGP from the PE to CE peer. So if we look at show IP route for VRF A, we are learning the OSPF route, but it's not in the BGP table. Okay, what would cause us to learn the route from the customer, but it not to get advertised to VPN v4 BGP? Probably the redistribution, right? Because once we learn the route in the VRF table, it doesn't automatically mean that we're exporting it into BGP. So let's take a look at the IGP config and show run section router. And we have the process that's going to the customer, which is OSPF2. And then under BGP, we need to redistribute OSPF2 into BGP. So that's the step that's missing here. So let's go to router BGP 123. The address family is IPv4 VRFA. And we're going to redistribute OSPF2. Okay, so if we show BGP, VPN v4, unicast all, we're now advertising the route to router 7. Okay, from 7's point of view, if we look at the show IP route, we see that we have 4444. Okay, let's check on the other end. Let's look at XR1. And in XR1, let's look at the show BGP, VPN v4, unicast all, or just unicast. And we are looking for the routes to 10, 10, 10, 10, and then also 7777. Okay, so we should see that these two routes got imported into the tables that are for VRF-A and VRF-B respectively. Okay, but what's missing here in the output of XR1? Why is it not importing these routes? If we look at the show BGP, VPN v4, unicast for the route distinguisher 11, prefix is 7777/32. It says the problem is what? Next hop is inaccessible. So just like any other BGP design, just because I advertise the route to you doesn't mean that you'll actually be able to reach whoever is the next hop for it. Where in this particular case, what's happening is that the route is going from 3 to 1, from 1 to XR1, and we're saying leave the next hop unchanged. Because the point of this is that we're trying to terminate the LSP from XR1 directly to router 3. We don't want to have the traffic go to router 1 first. So what this now means is that those IGP routes that we were leaking into BGP, we're going to need to advertise the loopbacks of router 2 and router 3 so that XR1 knows the regular iBGP route in order to get back to those next hop values. Okay, so specifically this needs to go on router 3, that if we go under our regular global BGP, so IPv4 unicast, under router BGP 123, we're going to go under address family IPv4, and then advertise 2222, and advertise 3333. Okay, so basically whatever PE routers that you have between the ASs, those are the loopbacks that you need to advertise in addition to the VPN v4 route reflector. So the VPN v4 route reflector, which is this one, this is needed to establish the VPN v4 session, and then these ones are needed for the actual label numbers that we're going to use for the final destinations of the traffic. So technically 1111 doesn't need to be labeled, but 2222 and 3333 do. Okay, so these should get over to the other side on XR3. XR3 is redistributing BGP into IGP. So the end result should be that XR1 should now know these two routes. Let's look at just the show IP route. Okay, it knows all of these as ISIS. So if we now show BGP, VPN v4 unicast, we should hopefully see the greater than sign, which we now do. And then if we look at our customers, which are 4 and 8, okay, we can see 4 got a log there. It must have been debugging IP routing. That, if we just show IP route, okay, we know how to get to 7777. Okay, next let's look from 8888 and show IP route. We now know how to get to 10, 10, 10, 10. Okay, so now it looks like everything is working in the control plane. We have the route advertisements between the end customers. Okay, next let's look at actually testing the data plane between them, and then what are the troubleshooting steps we would go through if we don't have connectivity between them. So from router 4, we're going to ping 7777. Source is going to be 4444. And then from router 8, we're going to ping 10101010. Source is 8888. Okay, then likewise on the other end, we're going to go to router 10 and we're going to ping 4444. Source, or no, we're going to ping here 8888. Source is 10101010. And then router 7 is going to ping 4444. Source is 7777. Now, the reason that I'm doing this from all of them is when we have a reachability problem, we need to think about, is this a one-way problem or is this bidirectional? Now, without having to look at packet captures yet, and we will look at this in detail to see the data plane format, one tool that you can use within the scope of the lab exam is to debug IP ICMP and debug IP packets and see if we're receiving the traffic in and then trying to reply back to whoever is the originating source. So in addition to doing these pings, on all of these routers, we're going to look at the debug IP ICMP. Then let's do these pings again. So from 7, we're pinging 4. And if we look at on router 4, let's look at the show log, and let's make sure that logging is on. Okay, so logging is enabled, console level is debugging. Okay, let's try this from 10 to 8. So 8's not receiving anything. Okay, let's try from 8 to 10. 10's not receiving anything, and then we're going to go from 4 to 7, and 7's not receiving anything. Okay, so this basically means it's a bidirectional problem between them. Now, one way we could get further information about this, because we need to see this within the core of the network, is let's say that we're going to advertise a new route into the customer table between the PE routers, and let's see if we can ping between those. So, well, actually, technically, we don't need to do a new advertisement because we're doing connected redistribution. So let's say between XR1 and router 3 that we're trying to do a ping between this address and this address. Because when we redistribute OSPF into BGP, we should be including that anyways. Where specifically, if we go back to, let's look at our addressing diagram, we're going to be pinging between the 10.4.11 address and the 10.3.7. So for XR1, let's look at the show route VRF A to 10.3.7.3. We do have a route to it. Okay, it's coming from BGP. Okay, then let's look from router 3's point of view and say, do we know a route in VRF A to 10.4.11.11? Which we do. Okay, it's coming from BGP. Okay, so next let's do a trace between these. Let's do a trace in VRF A to 10.4.11.11. And router 3 should automatically source that from its directly connected link. Okay, let's do the same thing on the other way. Let's say trace, and we're going to trace inside VRF A. From XR1, we're tracing to 10.3.7.3. Okay, so we can't even get one hop into the network from either of them. But they both have the routes installed. What this is typically an indication of is that the LSP is broken between them. So we next need to look at, when we're learning the BGP routes in the VRF, what is the next hop value, and then what is the label switch path in order to reach that particular next hop. So same as we would in regular intra-AS L3VPN, the only difference is that the next hop is learned differently between them. Okay, so let's look at this from router 3's point of view. Router 3 says the next hop is 11, 11, 11, 11. If we show IP route for 11, 11, 11, 11, it says this is learned through external BGP, and it's in the regular global table. Okay, the issue we're running into here, though, is that the MPLS label is none. And this is the key difference here between an IGP plus LDP binding versus a BGP label binding is that BGP does not include this by default. So when we're doing that inter-AS peering that's going between router 3 and XR3, they're going to advertise the regular routing information, but they're not going to do a translation or basically a swap of the label from the IGP binding into the BGP binding unless we specifically tell them to. Now, this is the desired behavior that you would want, though, because figure in the global table, this is where the internet's routes are. So if you were to do MPLS labeling for the internet, you would have over 500,000 labels. And the label space is not going to be that big. You're not going to be able to install that many into memory. So what we need to do next is between router 3 and XR3 is to enable this new address family, which is the IPv4 labeled unicast AFI, and then we need to tell them which routes do we want to specifically generate labels for. So from router 3, if we look at the show run section BGP, this means that on this particular peering under IPv4, we're going to say under router BGP 123, address family is IPv4, and this neighbor, we are going to send them a label. Okay, if we go to XR3, and you can see that this is disrupted because they have to go through a new capabilities exchange. And if we go to XR3 and show run router BGP, we're going to say that the address family is IPv4 labeled unicast. IPv4 under the neighbor. So under the neighbor, the address family is IPv4 labeled -unicast, and then we have our route policy in and out, just like the other one. Okay, the other difference here is that we need to go globally under BGP, under address family IPv4 unicast, and we need to say what routes do we want to add labels to. So we can do it for everything, it's just that the default policy is that you don't do that. It doesn't give labels to anything. So we need to say we want to do an allocation of labels. What routes do we specifically want to do them to? Right now we don't have a lot of routes in the global table, so we can just say all. But otherwise, in a typical design, you would use a route policy that says only those loopbacks that are for the PEs would be the ones that we want to allocate the labels for. Okay, if we commit to config, and then we look from router 3 and look at that same BGP update that we had before. So we're looking for the route to XR1's loopback. And notice, just like we saw in inter-AS option B, router 3 is saying I'm adding the MPLS BGP forwarding command to the link. Again, what this means is that we're enabling label forwarding for BGP bound labels, but more importantly, when we look at the show IP route connected, this is adding a connected route for the /32 address of the other end of the link. And this is fixing that same problem that we saw in option B, is that if you don't have a /32 destination, you can't label switch towards that next hop. So this also means that in iOS XR, we need to fix this problem manually. So if we look at the show MPLS forwarding table for 10.3.13.13, we have a pop label for this. But if we go to XR3 and say, what's the route for IPv4 unicast to get to 1111/32, it says it's eBGP, and the next hop is 10.3.13.3. So we need to know, do we have a label for this? If we look at the show MPLS forwarding table for the prefix 10.3.13.3/32, we don't have a label. Okay, or likewise for the /24, we don't have a label.